Hello, so in this video we're going to look at Unit 2, Graphing Trigonometric Functions. Unit 2 looks at 6.1 to 6.3 in the Openstax Precalculus textbook, first edition. So let's look at some notes, and you're more than welcome to pause and write them with me, or go to the shared folder or the link below and look at some of the notes inside of there as well. So first, we're going to look at the sine function, and we can see that with the sine graph, when we're graphing it, we're going to start at our center. We're going to go up to our amplitude, back down to our center, and back down to our amplitude, and that's going to kind of be the pattern. So when you kind of graph the sine function, and you're given that your amplitude, let's say, is 1, you're going to start with the origin. You're going to go up, down, down, and back up, and that'd be considered one period length, because you're starting back where you were. You're starting back at your center or your amplitude. So next we can look at the cosine graph, and for the cosine graph we actually start up at our amplitude, we go back down to the center, back down to our lower amplitude, and back up to our center, and we would go up again to our amplitude, and that would technically be one full period. So if we're graphing our cosine function, we know that, let's say it's 1, and our center is 0. We're going to start up at 1, go back down to our center, back down to our amplitude, and we're going to constantly have this graph, if you will, that we can create. And so when we're doing these problems and we're using cosine or even sine or most of the other trig functions, we can follow that pattern to create this graph. So next we have tangent, and for tangent it is very different compared to the sine and cosine, in the sense that it will have an asymptote. So for example, that it will never cross and it will never touch. However, the pattern continues for each period. So you could consider within these areas that's one period, you'd have a whole nother period over here, and so on. And so for tangent, it is more like that, and then you're having places where it will never cross or it will never touch. So we know that we are given a general form for our trig functions, being for sine and for cosine, and we can looking for the A, B, C, and D, which I would recommend trying when you're doing these problems, and that will give you a lot of information. So when you go to graph, it is very easy and straight to the point. So first we're going to try to find our A through D values, and then we'll graph our C, so our center. So in this case, 0, if we're looking at this sine and cosine graph. And then we want to graph our amplitude, and let's say if it's 1, so we have our amplitude going up 1 and down 1 from our center. And then we're going to find our period length, being our B. We're going to start at a point, so let's say we started at pi over 2 for cosine, then we'll continue this pattern. Similarly, if we found out that we're starting at 0, we could start at 0 and then go to pi over 2, 0, down to pi, down to 3 pi over 2, and back up to 0. And that would be our graph for the function. And so then typically we'll use our critical points, and we will find out what our actual points on the graph are. So we'll find the pi over 2, the pi, 3 pi over 2, 2 pi, and points within it, and then we'll just start graphing. And we'll look at whether the graph goes to the left, the right, up, down, and everything. And this gives you some ranges for each of the quadrants for the functions. So we can see that sine or an inverse sine is this range, our cosine and our tangent, in places where they are positive and negative. And if you remember back from the previous video if you look back at the previous video in Unit 1, we found that our trig functions were all positive in our first quadrant, and then we only had one function for each quadrant that was positive, so one set, and so the other two were negative. So that's kind of flipped when you have the arc of the trig functions. The inverse trig functions are fairly similar to the regular trig functions, being sine, cosine, and tangent. So for sine, inverse trig function, we create the same sine function graph, but then at the outer points on the amplitude, we create a parabola. And we'll do that for each one that is on the amplitude. And we'll do the same thing for our cosine graph. So every time it touches our amplitude, we will create a parabola going up or down. And then for the tangent is just the inverse, or it's flipped. So you can see that when we're using regular tangent, we create this shape, but when we're using our inverse tangent, or cotangent, we can see that it's flipped. So let's look at some examples, and you're more than willing to pause or look at some additional notes within the shared folder below, or even the textbook, which is a recommendation. So first, we're given y equals 4 sine in parentheses x plus pi over 12 in parentheses, and we want to find the various points for the a, b, c, and d, and then find the rest of everything that we need in order to graph it. So first, I would find the amplitude. You need to remember that y equals a sine of bx plus or minus d plus c is our form for sine. So we know that our amplitude is our a, and that will equal the absolute value of a, and that will equal 4 in this case. We know for our b, which is our period length, in order to find that, we will take 2 pi over the absolute value of b, and that will give us our period length. So we know we'll have 2 pi over absolute value of b being 1, and so we know that we're just going to have to go 2 pi length. For our c, we know we can see that we don't have a c, so we don't have a center, so we're just going to be right on the x equals 0, or origin, so none. And then we have our d, our phase shift. And for d, you're solving whatever is inside the equation. So we'll do x plus pi over 12, which is equal to 0. If we subtract pi over 12, we get that x is equal to negative pi over 12. And that will be your start of your critical point. So for our critical points, we will take our period over 4. And so we know that our period length is 2 pi, so we'll have 2 pi over 4. And we will add that on to our phase shift value. So for our first point, or our starting point, we know that it will be pi over 12. Our second point, we know that we're going to take negative pi over 12, and we're going to add 2 pi over 4 to it. But since we want a common denominator, we can multiply 2 pi over 4 by 3 and get a 6 pi over 12. And we can see that our second point will be 5 pi over 12. Our third point, we can do 5 pi over 12 plus 6 pi over 12, and we will get 11 pi over 12. Our fourth point will be 17 pi over 12, and our fifth point will be 23 pi over 12. So when we go to graph it, we know that our center is going to be 0. So we know that our center is going to be right here. We know that our amplitude is 4, so we can go up 4 and we can create our amplitude. We're going to start at pi over 12. We're going to start at negative pi over 12. So we can start right here. We'll go up to our amplitude, back down to our center, back down to our amplitude, back up to our center. And so now we did one full period, and we can just create our graph. So next, we know that we're given this function, and we know for cosine, we start at the amplitude, or our top, go down to the center, down to the amplitude, back up to the center, and back up to our upper amplitude, and we'll get this function. So we know we're going to start with our A, our amplitude, and our amplitude is equal to the absolute value of A, and that will equal 4. Our B is our period length. So we know that we're going to do 2 pi over the absolute value of B. And in this case, B is 3, so 2 pi over 3 will be our period. For our center, we can see that it'll go down the y-axis to -5. For our phase shift, we're solving whatever is inside our parentheses, or our brackets. So we'll go 3x plus pi over 4, and we're going to solve for x being equal to 0. If we subtract pi over 4, we get 3x is equal to negative pi over 4. And if we divide by 3, we will get that x is equal to negative pi over 12. And so we know that that will be our starting point and our first point. So we know that for our critical points, we're going to take period over 4. So in order to find our critical points, we're going to do period over 4, and we found that our period length is 2 pi over 3. So we will do 2 pi over 3 over 4, and we will get a 2 pi over 12. So for our second point, if we add 2 pi over 12 onto our negative pi over 12, we will get a pi over 12. For a third point, if we add a pi over 12, if we add a 2 pi over 12, we will get a 3 pi over 12. And for your fourth point, you will get a 5 pi over 12. And for your fifth, you will get a 7 pi over 12. So if we go to graph it, we know that our center was at -5. So if we look at our center being right here, -5, we know that our amplitude is going to go up and down 4. So we'll go up to here, being our amplitude, and right here, being our lower amplitude. We know that for cosine, we start at our upper amplitude, go down to our center, go down to our lower, back up to our center, and back up to our higher amplitude, and it creates one period. So next we can look at doing y equals of an inverse trig function. So we know that for this function, we know that it equals 1 over sine of theta. So we know that for our amplitude, it'll just equal 1. Our period length, if you go to do it, it is going to be 2 pi over absolute value of b. And since we don't have one, we can just put it equal to 2 pi over 1, or just 2 pi. For our center, we don't have one, so we know that there is none. And for our phase shift, we know that it's just going to be 0, so there is none either. So we'll just start at the origin. For our critical points, we know that our critical points is going to be period over 4, and we know that our period is 2 pi over 4, or we could reduce it to pi over 2. So we know that we're going to start at 0. Our second point would be pi over 2. Third point, 2 pi over 2, or pi. Fourth point would equal 3 pi over 2. And then our fifth point would equal 4 pi over 2 or just 2 pi. So we know that we're just doing the inverse of a sine function, and so since we know how to graph a sine function, so since we're going to start at our origin, we're going to go up, down, down, and back up. We'll create this function. So we know that if we start at our origin, or our x, or 0, we can go up to our first point, pi over 2, down to our second point, which would be somewhere in here, and then back down to 3 pi over 2, and back up to 4 pi over 2, somewhere over here, and back up to 5 pi over 2. And we can constantly create this graph, and wherever we have a dot on our amplitude, we will just create a parabola. So next, we can look at y equals 4 plus secant, in parentheses 3x plus pi over 2 plus 2. And so make sure that you can rearrange this equation first before you solve it, because sometimes students will forget that there's a plus and they'll make it as they'll multiply and think of it as a different function, which will totally give you an incorrect answer. So we would bring the 4 over, and so our new equation would be secant of 3x plus pi over 2 plus 6. So we know that our amplitude is our a, and we know that it equals the absolute value of a, and that will equal a 1, because we don't have anything in front of the secant. We know that our period length is 2 pi over the absolute value of b. And we know that our b in this case is 3, so we'll have 2 pi over 3. Our center, our c, is going to be moving up to the positive 6 on the y-axis. And our phase shift is we're just going to be solving whatever is within the parentheses or the brackets. So we'll take 3x plus pi over 2 equal to 0, and we're going to solve for x. So if we subtract pi over 2, we get 3x is equal to pi over 2. If we divide by 3, we get that x is equal to pi over 6. And so we know that that will be our first and our starting point. So we know that for our critical points, we're going to take period over 4. And so we can do our period being 2 pi over 3 over 4. And we know that we will get 2 pi over 12. Or pi over 6. So for our second point, we will take negative pi over 6 plus pi over 6, and we will our second point will be at 0. Our third point will be 0 plus pi over 6. So our second point, or third point, excuse me, so our third point will be 0 plus pi over 6, and we can see that our third point will be at pi over 6. Our fourth point will be at 2 pi over 6, or pi over 3. And our fifth point will be at 3 pi over 6, or pi over 2. So we know when we go to graph it, we will similarly do a cosine graph. So we know that secant of theta is equal to 1 over cosine of theta. So we know that for our amplitude, so we know for our center, we went up 6 on the y-axis. We know that our amplitude is 1, so we'll go up to 7. and then down to 5. We'll start up at negative pi over 6. We'll go down to our 0 or our 6, our center, back down to pi over 6, back up to pi over 6, and then back up to pi over 2, and that will be one whole period. And then whenever we have a point on our amplitudes, we will create a parabola on that point. So next we're going to look at our inverse trig functions. So we'll have arc trig function, or we'll have just an inverse trig function of cosine -1, sine of -1, and so forth. And we'll have to figure out where our possible ranges are, or what our possible degrees is. So we know that for arc sine, we're in range of negative pi over 2 and pi over 2, or negative 90 degrees to 90 degrees. And for arc sine, we can rewrite it as sine of -1 of -1/2. And we want to find out what our value will be. So we know that we can list out possible outcomes due to looking at the unit circle. So if we look at the unit circle, we can see that we want places where whatever, so we take our sine of an angle, theta, that theta angle needs to equal -1/2. So if we look at our unit circle, we can see that -1/2 is equal to, for sine, being our y value, at 210 degrees, 330 degrees, and -30 degrees. So we know that for arc sine, we have to be in quadrants 1 and 2. So we want anything on the right side of our parabola. So we want anything on the right side of our coordinate plane. So we know that 210 degrees would put us in the third quadrant. 330 degrees would put us in the fourth quadrant. And -30 degrees would put us in the fourth quadrant. But since we want to be negative, our answer would be -30 degrees, or negative pi over 6. So next we have cosine of -1 in parentheses of square root 3 over 2. And so we know that for cosine, our range is 0 and pi. So 0 and pi. So we're going to be in quadrants 1 and 2. So we want anything above the y-axis. And so if we look at our unit circle, we want to find places where our x value, where it equals square root 3 over 2. So for example, if we look at cosine of what angle will equal square root 3 over 2, we can look at 30 degrees, and we can also look at 330 degrees. So we know that if we go to draw it out, we know that 330 degrees would lie in quadrant 4, and 30 degrees would lie in quadrant 1. And so since it needs to be within the range of 0 and pi, our answer would be 30 degrees. So cosine of -1 of square root 3 over 2 would equal 30 degrees. So next we're going to look at tangent of -1 in parentheses square root 3 in parentheses. And so we can simply write it as arc tangent of square root 3. And so since we want our just a square root 3, we are going to be looking at our special triangles. And so since we know that square root 3 is only on our 30, 60, 90 triangle, that's the triangle that we're going to reference. So we know if we look at the triangle, we know that across from the 60 is a square root 3. Across from the 90 is a 2. And across from the 30 is a 1. And since we want a square root 3, and we know that if we look at tangent of theta, it looks at opposite over adjacent, or y over x. If we're using the 60 degrees, if we do opposite over adjacent, we will get square root 3 over 1, and we will find out that our answer is, in this case, 60 degrees. So next we're going to look at arctangent, but we want it to be negative square root 3. And so if we look at drawing it out on a coordinate plane, so we're going to look at quadrant 3, where we're going to have two cases. So for the first one, if we look at, so we know that tangent of theta is equal to opposite over adjacent, and we look at drawing out our triangle. So if we look at a 30 degrees triangle first, so 30, 90, and 60, we would have a square root 3, 2, and a negative 1. This time if we look at using our 60 degrees as our angle, or our theta, we can create a triangle of negative square root 3, our 90, and our 30. Across from our 30 is a 1, and we'll have a 2 across from our 90. If we look at our tangent of theta, or our y over x, and we want it to be negative square root 3, we would have to have a 60 degrees in order for even our negative square root 3 to be negative. And so our answer would be negative pi over 6, or negative 60 degrees. So next we're going to look at trig functions within trig functions. So we want the sine of negative 1 in parentheses sine of pi over 3. So if we look at our unit circle for sine of pi over 3, if we look at pi over 3 being 60 degrees and our sine being our y value, we can find that sine of pi over 3 would equal square root 3 over 2. And so if we look at doing our special triangle, since we want square root 3 and 2, we know that it's going to be a 30, 60, 90 triangle. And so we remember that across from the 60 is a 30 square root 3, across from the 30 degrees is a 1, and across from the 90 is a 2. And so we remember that sine of theta is equal to opposite over hypotenuse. If we look at using our 60 degrees, so if we go sine of 60 degrees, we get our opposite being square root 3, and our hypotenuse being 2. And if we decide to look at the 30 degrees, if we look at the opposite 1 over hypotenuse 2, so we'd get 1/2. And so in order to get the square root 3 over 2, we would need the 60 degrees, and so that would be our answer. So similarly, we can do it for the next one. So if we look at cosine of pi over 6 on the unit circle, if we look at the unit circle, we can see pi over 6 is 30 degrees, and for our cosine being x, we can see that it's going to be square root 3 over 2. So again, we would look at sine of negative 1 of square root 3 over 2. And we know that that will equal 60 degrees or pi over 3.